So today we're looking at the GTX 1060 trying to run Intel's version of DLSS. In other words, their machine learning trained upscaling algorithm called XeSS. And how does it work, and why am I concerned it might not work well on the GTX 1060? Well, here's the thing. So the way XeSS works, and this is very similar to how DLSS or FSR 2.0, that kind of thing works, is basically in a traditional rendering pipeline. The game renders the game at its resolution, applies some pre-effects, then there's temporal anti-aliasing applied, and then post-effects, blah, blah, blah. And where this gets inserted into the graphics pipeline is where the temporal anti-aliasing usually takes place. Now, this is a more complicated process than temporal anti-aliasing, so it actually takes longer to render than TAA, which would actually make your game run slower, not faster. But the whole point is for it to run faster. But here's the thing. What it actually does is, even though XeSS takes up more time, so this is now scaled based on time, the XeSS algorithm takes more time to render than TAA, but you lower the render resolution of the game. So say down from 4K to 1080p or something like that. And so now the rendering time is reduced. And so if the rendering time gets reduced by a larger amount, then XeSS increases the TAA part. Then you get a net gain 2 frames per second because this is computing your frame time. In other words, if the time to compute the frame is reduced, you gain more frames per second. So you're relying on the reduction of render resolution to gain you more time than XeSS increases the time to process when compared to TAA. So here's what's going on though. On Intel's proprietary GPUs, on their Arc GPUs, they have XMX hardware, which is basically a multiply and compute matrix accelerator. So it allows it to take a whole bunch of 8-bit operations, however you want to think about that, and compute them in parallel, all at the same time, and that is what is computing that XeSS algorithm. When you're running this on a non-Intel Arc GPU, even on like Intel's integrated graphics and things like that, or from GPUs from AMD or from NVIDIA, it's going to fall back to a DP4A instruction set, which allows it to compute, well, 8 of these in parallel, right? So we have 8 of them happening instead of, well, yeah, you get the idea. The problem is that XMX operations on the operations on the XMX core is 4 times faster. So in other words, the XeSS algorithm is going to take longer to compute on other brands' hardware. And the older that hardware is, the worse its support for this type of operation might be, the older and weaker it gets. So basically, if XeSS takes so long to compute that you're not actually gaining much overall time, because if this XeSS bit gets longer, even as the render resolution reduces, you end up not getting much net gain. So I'm curious what'll happen. This has been released at least into Death Stranding Director's Cut, which also has the FSR 2.0 algorithm, which is interesting. That's AMD's competitor, which is not machine learning trained, but is another temporal upscaler that operates based on the same idea. So in this video, I'm looking at comparing the performance gains and a little bit of the image quality, although I don't have time to do side-by-sides for this particular video. So we're going to be looking at the performance gains. So basically, which one gets computed faster, FSR 2.0 or XeSS on the GTX 1060? And then we'll also try it out in Shadow of the Tomb Raider as well, although that game doesn't have the FSR 2.0 algorithm to compare it to. And unfortunately, we just have FSR 2.0, not 2.1 in Death Stranding at the moment. So image quality-wise, the 2.1 version might actually end up looking a little bit better. All right, let's hop into the games. All right, we are now in Death Stranding, the Director's Cut edition. I'm not sure if the normal version got this update or not. Anyway, we're sitting here at around, I guess, 49, 50 frames per second in this scene, and the current graphic settings that we're on are 1440p, so I chose a higher resolution to see if these upscaling technologies can help us run a higher resolution on a GTX 1060. And then I went to the medium preset and then turned on temporal anti-aliasing to then compare to the upscaling here, both of which have their own version of TAA that would replace the one built into the game. So that's where we were at. Let's go ahead and kick on XeSS to its performance mode and see if we gain any performance. So we were at about 49 to 50 FPS. XeSS on the performance mode. Okay, we're up to 59 FPS. So that is a noticeable performance gain, although I do notice a bit of a blurring to the image, because at the performance mode, we're basically running at a quarter of the pixel density. Each horizontal and vertical axis is at a half resolution when we run at the performance mode. So basically we're running at 720p here. And we don't get that much of a performance boost to show for it. And this shows us that the GTX 1060 is slow at computing the XeSS algorithm. So it's capable of doing it, but only capable of doing it slowly. Now let's go up to the balance setting, which will run at a higher internal resolution than performance, but that means it won't gain as much performance by lowering it quite as far. All right, we're now at 55 FPS, so a small improvement over the native image, the native frame rate. I would say the image quality itself standing still looks fairly comparable. I think we'd have to move around and look at a lot of details to find a super noticeable difference. Let's go ahead and kick up to the quality mode and see if we're basically, I have a feeling we're going to be about even with native. Yeah, so we're at 51 FPS now, up from the 49 to 50 FPS we were at with the native. So basically at the quality setting, we're not really gaining any performance. So, if XeSS had a bit of a advantage, if you like its temporal anti-aliasing better at all compared to the one built into the game, I mean, you could look at it as a trade-off like that. Now, I haven't explored this game as much, but when I was playing around in Shadow of the Tomb Raider, there were certainly some pros and cons of the image quality of XeSS compared to native. At the ultra quality setting, I have a feeling we're going to perform worse than native. Let's see. Yeah, so we're now at slightly worse performance than native, and that's because the resolution here is only slightly less than native, so the performance we're gaining from that isn't as much as we're losing from this slow GTX 1060 trying to compute the XeSS algorithm. So that's why we're not gaining performance using the ultra quality mode. We're actually losing it. So what I'm interested in taking a look at now is testing out FSR 2.0 to see if that one computes faster and is then able to do a better job for us. So if we go with FSR SuperResolution 2.0, this has an ultra performance mode, which is probably not going to look very good, but let's see our performance gains. All right, so here we're up to 83 FPS, although I can tell you just looking at it, I can see fuzzing and aliasing to the character model as his arm moves around a little bit. I can see blurriness in motion, so I can tell you right now, this looks significantly worse than what we saw from any of the XeSS modes, but this is also rendering at a lower resolution because this is the ultra performance mode. And so I think it would only be fair to then, actually turn the settings up here a little bit. So let's go to the performance mode. Okay. The performance mode, we're boosting up to 70 frames per second. So certainly getting a much more noticeable performance gain here. Remember, XeSS at the performance mode, which I believe is about the same internal resolution, was only getting us to 59 FPS in this scene. So it's certainly more effective to upscale from this resolution frame rate wise on the FSR 2.0 algorithm. Although I will say I'm seeing more blurriness as his hand moves. I don't know how much YouTube compression would kill that, but it's looking like the disocclusion as objects become visible when an object moves past them was handled better by XeSS. Now notice this is only 2.0, not 2.1. So some of these things I think have been improved by the FSR 2.1 algorithm, but that wasn't added to this game. We only had the 2.0. Okay, we're now at the balanced setting, and we're at 63 FPS. So this is still more performance than we gained from the XeSS Performance mode, and certainly a lot more than we gained from the equivalent render resolution here. So it's certainly looking like FSR 2.0 is the the performance leader here. Going up to the quality setting, we're now at around 57, 58 FPS. So all the way up at the quality setting, we're getting similar frame rate, slightly lower, like 1 FPS lower than we got way down at the performance mode from XeSS. So a lot bigger performance gain here from the FSR 2.0 algorithm, certainly, when we're matching the frame rates. And by the way, that's not going to necessarily apply to every GPU, I don't think. It's just how fast, or I guess how slowly, the GTX 1060 computes the XeSS algorithm. So that's interesting. And that's as far as it goes. There's no ultra quality mode on this. So now what I'd like us to look at is go back to the native image. And I think that turned off TAA. I feel like the image looks kind of blurry here. So I'm going to go ahead and double check. Yeah, it looks like turning those on turned off TAA. So if we turn TAA back on, so comparing image quality-wise to the game's native resolution, as his hand moves past the grass and things like that, I don't get that blurriness that I saw with the FSR 2.0, so that's certainly interesting. All right, now let's actually look at the game kind of in motion a little bit. This is at native. Look at things like as his hands move past objects, things like that. We'll kind of run back and forth here a little bit. And now, since the only one that actually seemed worth using, maybe, from XeSS, performance-wise, was the performance setting, I'm going to try XeSS at the performance mode. The rest of the settings didn't really seem to gain enough performance to be worthwhile. I feel like my screen is instantly noticeably softer, a little bit blurrier than the native with TAA was. I don't feel like I'm seeing any issues with the disocclusion artifact specifically. I just feel like the whole scene just feels softer and less detailed. All right, let's go ahead and then compare that to the FSR settings in motion and see what we see. So we're going to have to turn off XeSS and turn FSR on. Let's go up to the balanced setting for FSR because we were able to gain more performance and it got us to around that 60 FPS-ish mark. Overall, I feel like I have a little bit more sharpness to the scene. It doesn't feel quite as soft. Again, I don't know how much gets lost to YouTube compression, especially when we're in motion here. Ah! Guy's gonna fall over. Forgot about that in this game. Anyway, I also feel like like I said, the disocclusion when his arms kind of swing past objects, there's a little more loss of detail. Oops. In motion. So overall, I'd say I do think that the XeSS image quality, I think I prefer slightly over FSR 2.0. But the performance gain from FSR 2.0 is enough better that I can set it at this higher setting. And at the higher setting, I do feel like FSR 2.0, I do prefer this to what we were seeing from the performance mode from XeSS. So interesting. Let's go ahead and take a quick look at Shadow of the Tomb Raider. All right, I've now fired up Shadow of the Tomb Raider, and we are at 1440p and I went to the medium settings and turned off motion blur. So motion blur off. That's why it says custom, as I went to just the medium preset and then turned off motion blur. And then on the display settings, we are at 1440p and currently XeSS is off. Now this is not a game that features FSR, so we can't compare it to that. So it's basically native resolution or bust until now we have XeSS as an option. Let's baseline our performance here. So standing in this scene, we're at 42 frames per second. And let's go ahead and kick on the XeSS algorithm. Let's go to the performance mode first. And okay, I believe we're seeing, okay, so we're up to 53 frames per second, so there's that. So we do gain performance, but it's not a huge amount. And once again, when we're all the way down at the performance mode, I do feel like I see a little bit of loss to the image quality. I think the fencing in the far distance looks a little bit more shimmery than we saw at the native resolution. So let's go ahead and also try out some of the other settings here. Let's go to the balanced setting. And at the balanced setting, we're at 48 frames per second. So again, it is a little bit better than we were at the native resolution, but like I said, I see a little bit more flickering to the image compared to native, and this is not a huge performance boost. Let's go up to the quality setting. And yeah, we're now at 45 frames per second, so pretty close to where we started. Once again, I can see a little bit of a flicker going on in some of the distant fencing, even here at the quality. Ooh, there's also ghosting on. Did you see that bird flying by? There's a lot of ghosting on it. Do you see the little trail behind it? If you're looking at the bird in the top right corner of the screen, you can see a lot of a ghosted image behind it. So it looks like the XeSS algorithm has a lot of ghosting here. So that'll bother some people, it won't bother other people, but something to keep your eye out on. Going to the UltraQuality setting. Let's see where we're at. The UltraQuality setting, look at Lara's dress now. Do you see the textures shimmering like that? That's something I noticed on my AMD GPU when I was testing out my 6800 XT. I still see some ghosting on that bird flying around, and I believe our frame rate is now slightly below where we started out at. So let me go ahead and actually kick this on to, well, off. And we'll get another comparison to the native image quality. So 41, 42 FPS. Now, the one thing I will say, though, is that XeSS, similar to what happens with DLSS in this game, some of the trees actually, like in the distance, the foliage, actually have more detail when we're using it compared to not using it. I think it's a level of detail bias setting that changes with those algorithms. So I'm actually going to go back to the, let's go to the quality setting, because we gained a tiny bit of performance, but we also gained some detail to the leaves in those trees. And I think like the white buildings, I can see a little more detail with the bricks and things like that. But like I said, there's some loss to image quality with the ghosting on that bird flying around. A little bit of shimmeriness to some of the fencing in the background, Lara's dress. Let's go ahead and take a look at the quality setting in motion here. Because like I said, there's pros and cons to the image quality here. It's not all negatives, and it's also not all positives. So we're getting at least a few more frames per second with some gains and some losses to the overall image quality. Personally, I think I might not use it because the overall performance gain isn't very much, and I think the gains we're getting to the image quality, to me, would be a bit outweighed, I think, by the negatives. I would find the shimmering on Lara's dress here to be a little bit distracting. I think the ghosting is the kind of thing that to me is a little bit immersion breaking, things like that. So Anyway, a bit hit or miss, not all pros, not all cons, but overall I think we can conclude that the performance of XeSS on the GTX 1060 isn't very impressive. Even at its most aggressive settings, you're not gaining a whole lot. So unfortunately, I don't think this is some magical solution to the upscaling question on a GTX 1060. I hope all of you have an excellent day.